Hello? How's everyone? How was lunch? First of all, I want to let people join. What a great event. Unbelievable, this is like the first SQL Saturday in Los Angeles because I've been to multiples of them and this is pretty amazing, so I'm blown away. Do you guys feel the same, by the way? Good, good. My name is Niran Even-Chen. I work at VMware. And I'm going to talk about how to virtualize SQL Server. Before I start the discussion, I just want to ask, how many of the folks around this room has virtualized SQL Server? About 50%? So other people, you guys didn't virtualize it, so it's all physical? Or you just don't know? Okay. How many do that on VMware? So kind of extended amount. Now you guys work the database, right? How many of you actually go and configure the vSphere or the virtualization side? A couple, right? Okay, that's basically what I see around, when I go around. Just a few words about me. I work at VMware. What I do is I'm the person that's responsible to write the best practices for SQL Server, or at least that's what I've been doing up till the last month. I've kind of pivoted a bit on my role, but for the past 2 years, I've been writing the best practices for SQL Server on VMware. So I've been testing SQL Server, creating guidance for customers, and enjoying also speaking at the SQL Saturday events, which is pretty cool. So if you guys do SQL Server and you know it's on virtual and you want to either configure it or double check what's going on or just know what's going on under the hoods, just find the SQL's best practices on vSphere, and that's the paper I wrote. So before I start talking about the how to virtualize SQL Server, usually the question I get if I speak with customers is, which SQL servers or which SQL Server instances can I run on VM, and which one wouldn't I recommend running on a VM? And usually my response would be, what is the maximum that the VM can hold? That will basically tell you what's the upper limit of a SQL Server that you can run on a virtual machine. And numbers in front of you, this is the latest from 6.5, vSphere 6.5. We can get up to 128 CPUs on a virtual machine, 6 terabytes of RAM, around 40 gigs, or more than 40 gigs per second, and 1 million IOPS for a single VM. Pretty cool for a virtual machine, right? So there's kind of not a limit. It does correspond to how you configure the virtual machine, though. You need to optimize the virtual machine. The more you need to work towards performance, and also corresponds to the underlying hardware. The virtual machine, virtual, it doesn't bring, the basic notion of supply and demand still works. You got to have the amount of resources to supply to a virtual machine if it needs to. So it doesn't create resources out of nowhere. Just a bit one word about the 1 million IOPS. This is kind of a hero number that a few years ago VMware did a study to see how much we can inject to a single VM. There was a ton of underlying SSDs, obviously, to make it work. There's a paper around it. Nobody needs that amount of IOPS for a single VM. But what is more interesting about that is just so you have kind of an idea of how it looks, is that the 1 million apps was done in under 2 milliseconds of latency. And I think that's the most important number. It's not the amount of IOPS that you shove into a VM, it's actually how much overhead the virtualization add. And the documented virtualization overhead is around 100 microseconds. That's kind of, and the reason I'm saying it is because there's a myth out there about virtualization and the storage stack, which exists kind of fairly because that's the way it used to be a few years ago. Since, I would say, version 6.0, there's no more storage overhead. So you can run any, the most virtualized workload on vSphere these days is SQL Server. Most customers virtualize the SQL Server, the biggest number. All right, let's talk about the how-to. What do I need to do? And I'm focusing my discussion on VMs that run SQL for production. SQL Server that is not production or performance is not the highest priority for your virtualization, it's very much a consolidation play. I want to be able to shove as many instances on one single server and being able to move resources around. But when performance is the highest priority for my VM, my SQL Server requires performance, then it's important that I don't move resources around, because if you have a SQL Server, for example, an OLTP database that is very transactional and requires fast transactions, waiting for a CPU to become available doesn't make sense. So if I even need to wait a few milliseconds for CPU to come from another VM, or worst case, even memory, then that won't achieve my performance requirements. And why am I telling you that? The biggest problem today that I see with virtualizing databases and SQL Server specifically is the kind of the battle between the requirement of the application, of the database, and what IT is used to do with virtualization. Up to a few years ago, most virtualization was around consolidation. Get me as many VMs on a single server, as long as I can provide service to the users and I can overcommit my resources on CPU and memory, I'm good, right? I can get the best bang for my buck when I buy virtualization. In the past few years, 3-4 years, there's a big move of virtualizing critical applications like databases. And then, IT needs to change their mindset. Those kind of VMs needs to have a different kind of special care. I do want to virtualize them because I get a lot of benefits, like moving VMs between hardware to hardware, being able to upgrade hardware or maintain it without downtime and all that kind of stuff. But I still need to achieve my performance and availability requirements, otherwise it's not production ready. So that's where I'm focusing my talk right now, is how to do that kind of configuration so that we achieve the highest performance. I'm focusing on performance rather than availability. It's a totally different discussion. So this is kind of the cheat sheet of my discussion. We start from the physical hardware. Everything runs on the hardware. I know we're virtualizing stuff, but hardware is still key to be configured correctly and to have enough resources on the hardware to supply the demand that the VM requires. Then I'm going to talk about the virtualization layer, the E6i host, like what do you need to do on the E6i host. Just one word, guys. I know maybe some of you or a lot of you are not versed in some of the terms I'm going to use. I usually do explain terms that I know are not for VMware guys, but if you have any questions, feel free to stop me. I'll definitely answer, or take you offline to another after the talk. Then we're going to move into the virtual machine, which is actually, if you think about it, that's where you guys the most needs to put your mind into, because that's where you can actually affect the way it's going to be configured. You do affect, obviously, the architecture of where you're going to deploy SQL servers when you discuss with your IT or VMware guy or whatever. But the virtual machine is where you have more control as DBAs or SQL Server owners. And last but not least, there's some things we do on the guest operating system that corresponds to virtualization. I'm going to talk about that as well. All right, let's talk about the hardware. First of all, the hardware needs to be on the HCL. I don't need to tell you. ES6i, which is VMware's virtualization hypervisor, is an operating system developed by VMware. So if it's not on HCL, either it won't work or it will work, but you're gonna have unexpected results. So you gotta have it on the HCL. Drivers and firmware needs to be up to date. This is pretty basic stuff that you're probably going to do on bare metal as well, right? Yes, and regarding power scheme, and I'm going to touch about it in a second as well. The power scheme in the BIOS, our recommendation is to set it up to always controlled. Now I know a lot of people put it on high performance, and I'm generalizing the terms, right? Different vendors call it differently, but some people put in high performance. Because we are kind of software defined, everything needs to be controlled by software. OS controlled would fit the best, because you can then set from the E6i policies throughout your environment to set it to high performance if you need to. And in other environment, you might want to reduce it to maybe balanced power savings, right? Hyper-threading, always on, okay? This sometimes misconceptions that result from misconception of recommendations from different vendors about hyper-threading. I can definitely tell you that hyper-threading is something you want to be enabled. You know, when you run Windows and SQL Server but directly on bare metal and there's hyperthreading, Windows kind of see the logical CPUs as if they're CPUs. Sometimes people think, oh, if I'm virtualizing, then I'm losing all that CPU power. Hyperthreading is not extra CPU power. It's just an ability to stress the CPUs more and get more out of the existing CPUs and the cores. We want to enable that on virtualization, not because we're overcommitting on the CPU, but because we want to allow the hypervisor more scheduling opportunities to move stuff around and to be able to control the CPUs better. So hyperthreading on. And NUMA. I'll spend time on NUMA for sure. NUMA is important to understand how it works on the physical layer, but more importantly on the virtual layer. There's definitely better performance you can achieve if you know what you're doing with NUMA. So let's start with storage. Why am I starting with storage? Obviously, this is a database's highest concern in many cases is about storage. And if you look at the slide here, what we add to the stack is this area. You see the Vim kernel? That's basically the hypervisor, right? That's we inject that into the storage stack. Throughout the stack, you have queues, right? There's adapter queues. There's queues on the virtual SCSI adapter as well. There's queues all around the storage stack. Queues are very important to understand when you optimize for performance, especially on storage. And why is queue so important? Because what happens is, if you set the queues in the wrong way, or you don't optimize for the amount of parallelism you can achieve from a virtual machine, you're going to get into bottlenecks. And if a queue gets full, that means that the queues above it that's supposed to come afterward going to start delaying stuff, right? I/O is going to start getting delayed, and all kind of problems that you don't want to get to. There's a couple things we can do on a virtual machine that we can't do even on a physical server that can help us achieve performance that's even better than physical servers in many times. So think about this. This is the guest device. This is the VM, and it has a guest device. It needs to send I/Os down. One of the things we can do is add multiple virtual SCSI adapters. Okay? Something that's not that easy to do on physical servers when you add multiple SCSI adapters, right? But on virtual machines, we can have up to 4. What does that allow us? That allows us on the OS level to have higher parallelism. Okay? That means that Windows, and consequently with vNext in a few months, Linux, which is funny for me to say that, but Windows will be able to send more I/Os at the same time down to the storage. Okay, so that allows the operating system to utilize the hardware better. So if I have a SQL server that has 4 virtual SCSI adapters, and it's running on either on a storage that's physically divided to different physical devices, or I'm using a very fast storage for like the all-flash arrays that we see today, I can ingest a lot more I/Os or write a lot more I/Os at the same time. And that's an optimization number 1 you want to do on a virtual machine. As I mentioned, take the differentiation between your traditional kind of storage that uses spindle drives or maybe auto-tiering and all that kind of stuff. In those kind of storages, if you want to really optimize for performance, you want to put your virtual disk devices on different physical storage devices, right? So storage groups or aggregates or whatever the storage vendor calls it. On all flash arrays, it's kind of less like that. You want to maybe have more I/Os to be able to provide those I/Os for the virtual machine. Does that make sense? Okay. Are you guys falling asleep already? I know you ate pizza, right? So we want to add those additional SCSI adapters. An additional thing we can do is change the type of SCSI adapter. The default virtual SCSI adapters that come on a virtual machine on vSphere, on VMware, is LSI logic. And the reason we do that is because that's the driver that exists by default on Windows. We want to be able to install Windows on that VM. LSI logic would work the best. But from a performance perspective, that is not the most optimized virtual SCSI adapter that you can use. And this is the case in many times that I come to a customer to see a performance issue on a virtual machine, and I see they use the default SCSI adapters. Doesn't make sense. The LSI logic, not only it tries to mimic physical hardware, which makes sense that it would be slower than a power virtualized adapter. A power virtualized adapter, which is called pvSCSI, is an adapter that knows that it lives in a virtual environment. It's optimized for that. Not only that, it has higher queue depth. So the default queue depth for LSI logic is 32. That's not high. The default queue depth for a pvSCSI adapter is 64. We can actually go and even increase that. Not always necessary, but if you have a really storage-intense SQL Server, you can increase the queue depth on the pvSCSI adapter up to 256 per device. So that is huge benefit. Change the SCSI adapters to pvSCSI. There's one exception on that. You cannot use pvSCSI on a Microsoft FCI, WSFC with FCI on top of it for the operating system. The operating system has to use LSI logic for WSFC with FCI. Always on availability groups, irrelevant. You can use whatever you want. So we said use multiple pvSCSI adapters. This is how you do it. The registry stuff. If you want, you Google it. It's pretty easy if you want to increase that. I can tell you that increasing the queue depths on the pvSCSI is not always necessary. It's really huge kind of databases. Needs a lot of IOPS that you might want to do that. There's another question that I get is, should I put my things on a smaller data store or a bigger data store? This is where the VM kernel queue comes into play. And I don't want to kind of confuse you with that, but the VM kernel, which is the vSphere hypervisor, also has queue depth on the HBA level per LAN. Okay, the default, it depends on the virtual on the adapter you're using, if it's fiber and so on. I think the default is 64 on QLogic and so on. You can increase that, but you need to be careful when you do that because it needs to correspond to what your storage can do. So think about the storage admin. They have ports that sit in front of your servers. They have the amount of queue, the amount of IOPS they can get at any certain time. The storage admins, they design that. So you need to make sure that you don't overcommit, oversubscribe ports on the storage, or create any situation that you create in queue full. Okay, any questions about storage, pvSCSI adapters, multiple SCSI adapters? What I was saying about FCI, well, I would suggest that if you're going to deploy FCI on virtual machines, you write WSFC VMware support. There's a knowledge base that says exactly what's the supported configuration for Microsoft clustering on top of VMware, whatever you run, AG or FCI or DAG or whatever, and you'll see there that you can't use pvSCSI on the boot device of the VM that's part of FCI. But there's other things you need to take care of. For SQL Server? Oh, from the VMware side. I don't recommend. So SQL Server, you can run into an NFS. Exchange Server, I don't know if you guys even touched that, cannot run on NFS. It's not supported. I don't recommend neither. VMware is agnostic. If you have an NFS that works the best for you, work with that, okay? All right. One thing I want to tell you, what we talked about is on a VM level, on a single host. Just so you're aware, in case you need it, we have technologies that correspond to cluster-wide level that we can set, called storage eye control. Basically, in case of congestion and contention between virtual machines on accessing a storage, for example, if you look at the screen here, think about those two VMs on the left that, I don't know, woke up in the morning, got crazy, and started hammering the storage, affecting other VMs that are using it. If you don't use any kind of quality of service technology, then other VMs are going to suffer. So the VMware has the ability to control that and set priorities for VMs, and even if you don't set priorities, to be able to prevent two VMs from monopolizing your storage access. You can enable that, and that can save you on a real IT day, bad IT day, right? I don't know, one VM got a virus, your entire environment gets hit because that VM is killing the storage, right? So storage out control is something you can use, just as a side note. Anybody knows what a VMFS in an RDM is? By raise of hand. Okay, one. Just so you know, VMFS is VMware File System. RDM is using raw device mapping, okay? It's an old debate for VMware guys. If you're doing SQL virtualization, you might encounter that. Should they use VMFS or RDM? The debate is over. You're going to use VMFS all the time unless you really require use RDMs. The only need to use RDM is not performance. It's, again, FCI, Microsoft Clustering. The shared drive got to use RDMs. Okay? Just one word about that. So this is, I mean, when you talk about storage, you get to this point a lot, right? How do I carve out my physical storage, and how do I place my SQL Server components on top of that? So again, first thing to remember, okay? If you're going to take all your SQL components and throw them on the same physical disk, something you would never do on bare metal, and for some reason a lot of people just go and do that on virtualization, you're going to get into trouble. Okay? You don't want your TempDB hammering the same physical storage that you got your data drives and the log drives, right? So if the VM that's running SQL is performance requirement and needs to have as much performance as you can get, you're going to start setting it up as if it was on a physical server, meaning you're going to have the right storage for your TempDB, the right storage for your log, and the right storage for your data, right? And that's streamed, right? Now everybody sees that I'm a goof. On the other hand, these today modern storages, all the all-flash arrays or storages that utilize auto-tiering, we don't carve them out like we used to, you know, with physical storages. We basically create like arrays and we divide that logically. If you're going to do that, the suggestion is, this recommendation would be that you make sure that the storage device you present for your virtual disk can accommodate the requirement of the aggregated VMs on it. There's another thing, right? We don't want to have a single storage device per virtual disk. Most customers would want to, you know, share different types of multiple virtual disks on as few storage devices as possible. So again, the case is the same. If you're going to create a bin, storage bin for your TempDBs, storage bin for your data disks, storage bin for your logs for multiple SQL servers, make sure it can accommodate the aggregated requirements of all the virtual disks that resides on it. I mean, it's pretty basic, but you wouldn't believe how many times I come in and I see, you know, oh, it's virtual. Let's throw it on the same storage device. But why is it not working? Guess why? There's not enough power to supply for the virtual disks. Yes. Yeah, I'll cover it, you know, in one word. Thin provisioning is no longer a problem. If you look at the new type of storages, they use only thin provisioning. Even Microsoft don't, Azure disks and all that kind of stuff use thin provisioning. So thin provisioning is becoming more prevalent on the market, but DBAs are known to be traditional, and I will not force your hand if you want to use thick disks. It depends on your company policy and the way you manage your stuff. I mean, it depends on the storage device and depends on how it's set up. Some storage devices, you won't feel a difference at all. From most storage device. VMware came out a few years ago with technology called VAI. Okay? VAI. Yeah. Well, it's an API that allows the storage to do things offloaded. So the VMware staff offload a lot of the operations to the storage. Thin disks, for example, on that case, would be the same kind of performance as thick disks. Okay? So need work with the storage admin. Okay, this is the storage that talk about the compute, right? CPUs and memory. The first thing I'm going to talk about is NUMA. Everybody knows what NUMA is? Non-uniform memory architecture? No? Okay, 2 words about NUMA so you're aware. As you guys know, as the more the servers become bigger, the more cores we have on sockets, right? And what we got to is the bottleneck to access the memory at some point. So what server vendors created is non-uniform memory architecture servers, basically kind of partitioning the CPUs and access to the memory, so CPUs can access memory faster with many cores on them, right? Kind of simplifying what NUMA is. If you take the Intel, the new servers, and also AMD, it kind of corresponds to socket, right? So a socket would have its own memory bank that's called local memory, and if the CPU needs to access memory remotely to go to another socket's memory, that would introduce latency. Okay? SQL Server, good news, is excellent at NUMA management. Okay? So we're good there. VMware is NUMA aware totally. So VMware will always try to keep your VM's CPU and memory local as much as it can. But you need to be aware of that you're not making mistakes that will cause your VM to remote fetch memory. Okay? So what do we do? Let's move this on. First of all, NUMA is virtual NUMA is something that came out on VMware that basically says that if you create a VM that is wider, is bigger than the physical NUMA it resides on. I have an example here. Let me jump a few slides. So you see here what you see on the left. Okay? That's a VM that fits into a NUMA node. It has the amount of CPUs that fits into a single NUMA node. Okay? Yeah. This is a VM that doesn't fit into a NUMA node. It's wider. And what vSphere does, it presents the underlying NUMA architecture. It basically carves the amount of CPUs the VM has to 2. It can do more. And present a virtual NUMA architecture to the Windows side. That will allow SQL Server to take advantage of that virtual NUMA architecture and create its own NUMA awareness. And vSphere will take those virtual NUMA nodes and will place them to be local as much as it can. Okay? So you want to be able to achieve NUMA locality of 100%. If you get NUMA locality that's less than 100%, you're starting to degrade performance because it's starting to fetch memory remotely. So how do we do that? So as I was saying, NUMA gets enabled by default more than 9 virtual CPUs on a virtual machine. But in order to create a virtual NUMA architecture, the VM needs to be wider than the physical NUMA node that the server resides on. Okay? So you basically create the VM wider. You need to know that if you do that, you're going to create virtual NUMA, and I'll explain why in a second. There's a feature in vSphere, and this is a common mistake. There's a feature in vSphere that's called CPU hot plug. Have you heard about that? You can add CPUs on the fly to a virtual machine, right? If you check that box that you will be able to do that on a virtual machine, you're going to disable the ability to do virtual NUMA on that virtual machine. So I go to customers, and they say performance is not the best on a large SQL server, and I see the checkbox, and they set it up on the template, meaning all the VMs they deploy, the CPU hot plug is checked. They didn't know it disabled the ability to do virtual NUMA. Any VM that grows wider than the physical NUMA node will automatically be degraded a bit because memory will start to fetch remotely. So CPU hot plug disables it. By the way, Microsoft in SQL 2016 enabled by default something called soft NUMA, which is Microsoft's technology to carve out additional logical NUMA management on the SQL side. That doesn't conflict with vSphere, totally fine. The interesting part about it is that if soft NUMA is enabled, SQL Server cannot have automatically added CPUs, right? So the whole idea of adding CPUs automatically, I would say stay away from if those are production grade virtual machine with SQL Server that you're probably going to need them to be big, right? With lots of CPUs. You want to also make sure that the host that you're running on, and today I think it's by default on all the physical servers, NUMA is enabled. The setting is sometimes called memory interleaving, okay? It needs to be disabled if it's memory interleaving. I think it's HP servers. Now, there's a change that happened in the last version of vSphere, and I want to explain. So You guys, how many of people know what version of vSphere your SQL Server runs on? Know what version it is? No one. Okay, so you should get some familiarity because the differences between versions. And if someone that manages your vSphere side may be not aware, you want to know exactly what's going on. So the latest version that came out is 6.5. Okay? Up to version 6.5, there's a feature that you can go to a virtual machine and set it up instead of having CPU sockets, virtual CPU sockets, you can set it up with virtual cores. So if I want, let's say, 16 CPUs, I can have 16 physical virtual sockets, or I can have, let's say, 2 sockets and 8 cores each, virtual, okay? Up to version 6.5, if you have done that, you would basically tell vSphere what's the virtual NUMA architecture that VM going to have. And if that virtual NUMA architecture did not fit the physical NUMA configuration, you would create, again, inconsistency and performance degradation. Why would anyone change the virtual cores? Again, think about SQL edition limitations, right? SQL standard on 2014 as, I think it's 4 or 16, the lesser of 4 or 16 sockets or cores, right? So people want to set multiple cores, virtual cores, just for licensing purposes. Or maybe some software or operating system can't ingest all those cores. So you want to be able to control that. So up to version 6.5, you had to really be careful doing that. And the recommendation was to keep it as a single virtual socket on all the CPUs. If you need 16 16 CPUs on a VM, sorry, you would set it up to 16 sockets, single core. 6.5 would change that at VMware. We realized that people want to change the number of cores per socket for different reasons. So we disconnected the dependency between virtual sockets and the physical NUMA configuration. So you can set in 6.5 any kind of, any optimized number of cores per socket configuration. The underlying vSphere will create your optimized NUMA configuration, virtual NUMA configuration based on the physical servers. Got it? So NUMA, bottom line, be careful what you're doing. Make sure that you correspond to the physical servers you run on. Again, there's some linkage there. And know that if you're gonna grow wider than the physical NUMA node, there's some implication to that. Make sure your SQL Server takes advantage of the virtual NUMA configuration. Okay? One more thing. The virtual NUMA is set based on the amount of CPUs, not memory. A mistake that someone can do is to cross NUMA boundaries with memory, but not cross some NUMA boundaries with CPUs. That will create a situation that you force your VM to fetch memory remotely from a remote NUMA node. Make sense? Okay. This is something we see sometimes. There's a setting in Windows. When you set Windows to balanced CPU consumption, power management, Windows can go into a mode called CPU parking, okay, core parking. That can degrade performance. Why is that? Because when Windows goes and parks your cores, it sends a command to the CPUs to go into sleep mode kind of thing. vSphere takes that and schedules your virtual CPU out of a physical core, okay? And when you bring it up, again, you incur some latency to go back to the CPU, right? That comes into the point, again, that for performance-bound virtual machines, you want to make sure that you're in high performance on your Windows side, okay? And also, there's another setting you can do to disable CPU core parking. Just Google that or check the presentation. I'm going to share the presentation on the SQL Saturday website. And I almost forgot to say the most important thing about CPU, okay? So CPU is the most overcommitted resources that usually VMware admins want to go for. Memory, that can be tricky. You can overcommit depending on the workload and up to a certain amount. CPU, it's fluid, right? There's one virtual CPU would access it, the next second another one would access it, right? If I want to take CPU from one VM, I basically deschedule it from the CPUs. It's faster to respond on that end. So VM admins feel more comfortable in overcommitting CPUs. Overcommitting CPUs means that, let's say you have 64 physical cores on your system, and you're provisioning more than that on that physical server, at that precise second, you created overcommitment and contention because two virtual CPUs try to access the same physical core. Okay? Hyperthreading or not hyperthreading doesn't matter here. They're trying to access the same physical core. vSphere needs to decide who comes in first. When it comes to transactional databases or maybe DSS databases that run, you're going to run two huge DSS that runs the same queries on the same CPUs, you're going to get into contention, you're going to get into problems. So if performance is the highest priority for your VM, you don't overcommit on CPUs, at least not at the beginning. So I've just virtualized my SQL Server. I'm going to put it on a server that has enough cores to accommodate for all the virtual CPUs on top of that server. You run it maybe 1, 2, 3 weeks. It runs in a balanced way. You can increase maybe overcommitment to 2 to 1. Okay? It's production, so don't go too much. If it's not production, I've seen people go dev environments even 50 to 1 because they're not using all the VMs at all times. But on production, again, I mean, if your VM admins did not get that you're virtualizing a critical database rather than tier 2 applications that you can consolidate, you better make sure they do it. You're going to harvest all the benefits of virtualization without hurting any performance. Memory. Memory is easy. Do not overcommit on memory, okay? Do not make your database page not on the operating system level, you know that, but definitely not on the vSphere side. This is just a representation of what's going on with memory, right? We got 3 layers of memory management. We got what's going on a host, right? The host, meaning the E6 server. That's the memory that it's using. Then there's the guest, the memory it allows to the VM, that it provisions to the VM. And then the VM, the operating system Windows, provisions memory to the application. What you do on the SQL side, continue to do the same. Just make sure that you don't overcommit your memory on the physical server, so there's enough physical memory to go around to your SQL databases. Right, large pages can help using large pages. Anybody using large pages for the SQL Server here? Okay, large pages can help. It can help from a CPU management perspective. So the larger the pages, the less TLB lookups, right? The less TLB lookups, the less TLB misses, the less CPU overhead, and so on. So large pages can help. The caveat here is very simple. If you set large pages up, SQL Server might boot up slower than what it would without large pages, so it's kind of trade-off. I would definitely say experiment with it. Make sure that it fits what you need. It doesn't affect your SLAs. And memory reservations is something you do on the vSphere side that you tell the vSphere, basically tell vSphere, E6i, I want my memory on that VM, I want it to be physical at all times. If you have contention, do not page my memory out or compress it or I don't know, memory compression or balloon it. The ballooning, by the way, is the ability for vSphere to tell the operating system to page out, right? So that it can use the memory without the hypervisor doing it for the operating system. You want to make sure nothing of that happens on a performance-bound VM. Reservation tell the vSphere side to make sure it's physical. If you don't overcommit on memory, meaning if you provisioned VMs that are memory that is less than the physical memory on the physical server, reservation doesn't actually do anything. Because there's enough physical memory to go around, nothing would be paged. vSphere will not touch it. There's enough physical memory to give to the VMs. But reservation can, I would say, future-proof it to be subtle. Someone can make a human mistake and move stuff to your server or move your server somewhere else or whatever. Setting reservation makes sure that no matter what's going on, your VM is protected with physical memory. Okay? The downside or the caveat with using memory reservation, it can affect your HA. vSphere provides high availability built in. It can affect your HA if there's no server that it can accommodate for that reservation to recover on. That's one thing. And also, think about this situation. You put your SQL servers on a vSphere cluster, let's say with, I don't know, 10 physical servers, and you set it up to be able to accommodate 2 server failures. right? So the environment saves enough resources for 2 physical servers to go down. And then you get 4 down. You get 4 down for some reason. I know, one power outage on a rack. In that case, you might want to use those technologies that I said never use it on production, because in that case, you're going to say, hey, I prefer my database up and a bit degraded than being down altogether. Reservation might prevent you from using that. In that case, you might want to tweak that. Good news, reservation does not require rebooting the VM. I'll tell you more than that. You can add memory to VMs on the fly. There's a checkbox you need to check, but only do that in vSphere 6.0 and up. The way it used to work before vSphere 6 is that if you if you dynamically added memory to a VM, it would add it to virtual NUMA node 0, creating kind of an imbalance. We fixed that in 6.0 and up. So vSphere 6.0, which is a long time on the market, you guys are probably, most of you on 6.0. You can add memory on the fly, just need to check that box. It's totally fine. I would just urge you, do not use ability to dynamically add resources as your sizing methodology. Size your stuff right, okay? All right. Let's talk about network. And we might have time even for more questions. So, from a network perspective, you see that first line? That's kind of outdated. If your environments probably have converged networks, meaning 10 giggies, so you don't use a NIC for each type of traffic. You're probably going to have different types of traffic running on the same physical NICs, right? Even from multiple VMs. So there's some type of traffics you want to make sure that you have enough resources for. For example, availability groups replication, okay? I mean, think about it. Availability groups that works in synchronous mode, if it doesn't commit in one side fast enough, the other side suffers. It's synchronous. So you want to make sure your network has the lowest latency you can achieve for that. You want to make sure that if you can put it on a network that doesn't get affected by other type of networking that's heavy, like vMotion. Everybody knows what vMotion is? No? Are you guys fall asleep? No? vMotion is the ability to move VMs on the fly from server to server, right? When you do that, you replicate the memory between servers. That's very heavy on network. You want to maybe not put your AG replication in the same place you put vMotion on. So that's the type of thinking that your VM architect needs to, and your network guys needs to make sure that they do. But good news, just like on storage, we have the ability to do I/O controls on network. So we can set up a situation, a policy that says, if I have contention on my bandwidth on the 10 gigs, and I got like priorities, it's proportional priorities we set. It's called shares. We say that type of traffic has 50 shares, that type of traffic has 100 shares. If both of them are trying to utilize the network cards 100%, that will get double the amount of bandwidth than that one. And double the amount of bandwidth and half of the latency. And it's very accurate. So network I control can really help you in those situations. You can use something called NIC load-based teaming. So again, think about this. You got multiple NICs in your physical server. vSphere needs to decide your VM, and you're using multiple NICs teamed on that physical server. E6i, vSphere needs to decide your traffic needs to go now on that NIC. Okay? There's different kind of load balancing algorithms you can use. The load-based teaming allows vSphere to see that if one NIC is congested over 75% for more than 30 seconds, to move stuff around. So that's the only load balancing algorithm that actually looks at load. The other ones is kind of even those that are aggregates like lags, they still do kind of a round robin. The only one that does load-based teaming is load-based teaming. So you can utilize that. That's pretty good. If you're going to use jumbo frames, make sure that jumbo frames is set up the same way all the way. The good thing, we got health checks in vSphere that can tell you if there's jumbo frame mismatch on the virtual side. But if, let's say, you're using HP blades and your virtual connect is not set up with jumbo frames, and you set up jumbo frames on the VM side and on the switch side, you're going to get into network problems. So jumbo frames is to be set up correctly. VMware tools. VMware tools is the package we deploy on virtual machines with drivers and firmwares and stuff. With drivers, make sure this is set up to date. And the most important most important recommendation on the network, use a driver called VMXNet3. That's a para-virtualized network driver. It knows it lives in the virtual world. It does not try to mimic a physical NIC, okay? For example, it will have a shared ring buffer between the virtual and the physical, because why do I need to copy packets from the virtual NIC to the Vim kernel if they're basically the same, right? So use VMXNet3 throughout your virtualization. It's always better than the default one. Okay, RSS. RSS receive side scaling. Got some animation here. That's what it's doing, okay? It's basically pinning all the network computation on CPU 0. The other ones are just standing outside and cheering. So it would cause some performance issues if you're gonna have CPU 0 get full 100%. So what you want to do is enable RSS in Windows. Okay, you go into Windows, you go into the network adapter, you go to VMXNet, you go to configuration, and you set up RSS enable. That will allow Windows to utilize all the virtual CPUs it gets for network processing. Okay? Again, a very good suggestion. I know there was issues with that in 2008, SQL 2008, or Windows 2008, but good recommendation to have. In regards to clustering, I get into many discussions with customers about Microsoft clustering. Should I cluster, right? vSphere has capabilities for high availability built in. Why do I need to do Microsoft clustering on the VM? So my answer is very simple. If you got misled by anyone, I want to correct that right now. Our technologies do not try to replace Microsoft clustering. What Microsoft clustering, Windows Server failover cluster can do, we don't try even to do. So when you take a SQL Server, single instance SQL Server, and you throw it on a virtual environment, okay, it will automatically be protected for high availability, maintenance free. If a server crashes, the physical server crashes, it will recover on another server, okay? So that's a single instance, okay? There's no failure, it just recovers on another server. But the RTO, the time it takes, is longer than what Microsoft clustering can do. The vSphere high availability is around 4 minutes. Okay? So if your SQL Server can suffer 4 minutes downtime in case of a physical server crash, feel free to not use Microsoft clustering. On any other hand, and try, how many people here needs lower than 4 minutes recovery on their production databases? That's it? You guys can, yeah. There's another thing, right? Patching. When I want to patch my SQL Server, I want to be able to do rolling patching. Not all SQL servers might need it, but my production one, I want to reduce the amount of downtime again. If you're going to use single instance SQL Server on vSphere, you cannot do rolling patching. You have to shut down the database because it's a single instance. Okay? I cannot fail over. I can fail over it. I can vMotion. I can move it around as much as I want to. But if I want to patch SQL or Windows, it's kind of becoming a problem. So if you need to do that, you're going to have to use Microsoft Cluster on top of vSphere. And the last thing is application level resiliency. We do not monitor the SQL Server. If SQL Server crashes, we can protect from an operating system failure, meaning blue screen, we can reboot the VM, and the server crashed, we can move the VM. We can actually achieve 100% availability on the physical hardware, meaning if your physical server crashed and you had SQL Server on it, no downtime. It continues from another server with 0 downtime. We can do that under certain limitations. Great technology, but we do not protect from a SQL Server failure. So your SQL Server service down, there's nothing you can do unless you're going to use third-party software or Microsoft clustering. Now here's the good news. Tons of customers are running Microsoft clustering on vSphere. And the reason they do that is, first of all, it does not contradict each other. Actually, our technologies enhances Microsoft clustering, and here's why. You're going to use, let's say, Microsoft clustering FCI or AG running on vSphere, okay, on 2 physical servers, and once the physical server crashed, Microsoft clustering, Windows Server failover clustering will recover SQL on the other side, right? But what about that failed server, that failed node? VMware will recover that automatically. So I have customers that have hundreds of Microsoft clustering instances going on, Okay? If one node failed, they can go 2 days without even knowing that they had a failure. Now, most of the time, you want to go check what happened, because if the other one dies, your SQL Server is down. The vSphere will take care of that and elevate your availability. SQL on Linux is coming down the line. Anybody played with SQL on Linux, by the way? Okay, I have. And we are working on creating guidance around it and so on. That would require different kind of techniques for availability. vSphere will also enable to help over there, right? So vSphere availability enhances Microsoft clustering, bottom line. If you need Microsoft clustering, use it. If you don't, it's fine. vMotion, I already mentioned, vMotion is the ability to move a VM from one physical server to another with no downtime. The enhancements in 6.0, which is a year or 2 years ago, I never remember when the version came out or not. Basically, we allow to move a virtual machine now, not only between physical servers in the same data center, we can move it between any data center to any data center that has 150 milliseconds latency between them, round trip. That means Vegas to New York, okay? No downtime. Now, obviously, you have a 1 terabyte database, just copying it to the other side, that might take time. So the ability to utilize what's called replication-based vMotion, that means that you replicate it constantly, and only when you need to move it, you just switch it to the other side, we can do that. And this technology, VMware strategy right now is around hybrid cloud and multi-cloud approach. This comes perfectly into play. You guys, I don't know if you heard, VMware is coming out with VMware on Amazon, on Azure, AWS. So we signed an agreement with them. We will allow single pane of glass if you put your stuff on VMware on Amazon, basically natively, VMware running natively on Amazon servers to your on-prem. So you can create like a single pane of glass and seamless movement between Amazon or IBM or whatever VMware-based cloud you can use. So can I vMotion Microsoft clustered VM? Yes, just need to make sure that you don't create a situation of latency that causes unwanted failovers, okay? We don't want unwanted failovers on Microsoft clustering, right? So in order to achieve that, you can increase the heartbeat threshold for Microsoft clustering so that it's less sensitive, which is actually a recommendation that I would do anyway. I mean, backups can cause latency or whatever, so increase the latency on the heartbeat between the virtual machines or between the Microsoft clustering nodes so that it doesn't cause failures if there's some latency. Why would vMotion create latency? When you do vMotion, it basically does the memory replication, and when it switches over to the other server, might be a small pause that can cause a failover. But if you increase the heartbeat, that won't happen. There's another corner situation, which is called standard page send, that you need to be aware if you virtualize in a very heavy, very transactional SQL database. I'm talking very heavy, 64 gigs and up kind of database that hits very hard. And the situation is, if you're trying to vMotion that kind of database, and let's say you're hosting a farm of those type of databases, you need to architect around them because you want to be able to use vMotion. It's very, it's crucial for what we do. But what happens is, if the memory pages are getting dirtied faster than being transmitted to the other server, vSphere would have to go and stun that server to allow it to move. And that would create some degradation. So what you want to do is have enough bandwidth for vMotion, or utilize multiple NICs. You can do that. Just search multi-NIC vMotion. And that will almost eliminate any situation like that. So if you have a farm with huge SQL servers that are very memory intensive, I don't know which SQL server is not, but very memory intensive, make sure you architect your vMotion around that. And with that, I think we're done. We got 5 minutes for questions. Yes. So your question is, if there's a limitation of the amount of cores I want. You know what? Hold on. Hey guys, thank you for coming. Let's do the questions after this, but thank you very much and great event. Thank you for having me. Okay, shoot your question.